All right, problem number one. Problem number one. So we have a velocity time graph with a truck. It's going constant velocity, passes by a police car. Police car accelerates. It can only accelerate so long. It's up to 60 meters per second, and then tails off at its speed. The question is, there's a series of questions we ask about. The first one is, when are the cars traveling the same velocity? Well, this is a velocity time graph. This is a velocity time graph. I'm simply going to read the graph. So I can go and look at it and go, aha, I'm going to read the graph. I'm just going to get my pen to work here. There it is, okay. I get my pen to work. And so the question is, whether the velocity is the same. Well, the velocity is the same where the graphs cross each other, right? So the velocity is the same right there because it's a velocity time graph. Okay. So since the velocity time graph, they have the same velocity when they have the same speed. The same speed in this case would be 40 meters per second, and they have that at 8 seconds. This velocity time graph, I simply read the graph to figure out when they have the same velocity. How far both cars travel when they reach the same velocity? Well, that would be this point right here at 8 seconds. So the truck's been traveling at a constant 40, so it would make a rectangle to the area of the curve. This area of the curve would be the area of the curve would be a rectangle, 40 times 80, which gives you 40 times 8. And so that's 320 meters. And so the truck has done 320. How fast has the police car gone? Well, this is a triangle, right? It's not been going 40 the whole entire time. In fact, initially it starts at rest, so it's going to be going half as far. Or we can just simply look at the triangle as well. 1/2. The base is 8. The height is 40. And I get 160 meters. So again, because it's a velocity time graph, I want to know how far when they had the same velocity. Well, how far would be at 8 seconds? How far are they 8 seconds? Well, rectangle for the truck, triangle for the police car. That's how you make that work. Okay. Next question is, at what time did the police car reach the truck? Now, initially, there's kind of an instinct of, well, the police car reaches the truck right here. But it's only gone 160 meters, and the truck's gone 320 meters, so it's 160 meters behind. So they have not yet caught the truck. So the question is, well, how are you going to figure that out? So the answer to that question is you've got to start guessing and checking. The first place of interest is if you look at 12 seconds, the triangle stops there. So that's a good place to check, because either I want to check to the left, I want to check to the right of that point. If the police car's got more distance and it's caught the truck, it's got less distance and it hasn't caught the truck yet. I'm going to check out at 8 seconds, or at 12 seconds. At 12 seconds, the the truck would have gone. The truck would have gone 1/2, 12. No, the truck's not 1/2, it's a rectangle. I'll get this right yet. The truck would have gone 12 times 40, which is 480 meters, I believe. The police car is in a triangle, is it not? So the police car is going to be looking at 1/2, 12 times 60, which is 360 meters. So it's gotten closer because it's going faster now, but it still hasn't caught up. Okay, it's still 120 meters behind. At this point, it's 160 meters behind, so it's getting up. At this point, the police car then goes constant speed, which means that from here on out, it can be just a normal. We know what it does every second. So if I were to set up a distance time graph, and I just graph time chart, so we have distance of the truck, distance of the police car, we would know, starting at 12 seconds, the truck is now going 40 meters every second. So it would be, so first of all, this is the truck is 480 meters. And this is the police car at that point is 360. Okay. And so then at 13 seconds, we have 40 more for the truck. So that would be 520 meters. And we would have 60 more for the police car. So that's 420 meters. Okay, we can do this all day. We have 14, 560. And then this would be 60 more, so that would be 480 meters. And I would note that we're 120 meters at this point. Now we're 100 meters apart. Now we're 80 meters apart. And I can start to figure out what the pattern is and kind of jump ahead and guess that, well, it's not going to happen the next second or the second after that. But I can also just keep plugging along because I can be boring as heck and just do it once every second. 520 meters. Oh, now we're 540 meters. So now we're 60 meters apart, and so on and so forth. You can skip ahead and go 40, 20, 0. So that's 16, 17, 18. And then double check by counting these up. And I go 640, 680, 720, 600, 660, 720. Check, we're in the same place. So it happens at 18 seconds. And it happens and it happens 720 meters down. Oh, sorry, 18 seconds is the time, and 720 meters downrange is when they run into each other. Now, another way to look at this is to go, look, the difference between the areas is this little zone right up here, right? And so that's how much the police is gaining on the truck. So if this doesn't float your boat, you want to do something faster, you might say, well, it's the area of this is how much it's gaining, and this is 20 by the time, correct? If it's 20 by the time, then you knew at 12 seconds you were 120 meters behind. So you would just do 20 times what time? In other words, when would the area of this be big enough to equal 120? And then the time would be 6 seconds. Well, 6 seconds added on to 12 gives me my 18 seconds, and I'm good to go. That's another way you could look at it. Okay, and so there is that. You could also say, well, I know the truck's 480 plus it's going to go plus 40 times time. What does that equal to 360 for the police car plus 60 times its time? Now that they're going constant speed. Any of these methods will get you the same answer, including guess and check and keep plotting along until you get the same answer. Any of these are fine. All these are welcome. And what should happen, because most of you are good enough at mathematics to pull this off, is you should start to make this pattern. And when you get to a certain point in the pattern, you should be like, well, I'm going to skip ahead to the finish line. Okay? All right. So that should hopefully get you through 1.9 problem number 1.